Our next step is to estimate the ground state energy for H. One method is substitute a large number of different wave functions get phi into the LHS of equation 3 and pick the one which gives the smallest answer. We know that the expectation value of H is greater than or equal to the ground state energy E0, and if we use different wave functions get phi to find the expectation value of H, the one which is smallest gives the value of E0. The smallest answer is the ground state energy E0 of the system. This is one method. Another method is consider a trial wave function get phi as a function of some continuous parameter alpha which can vary. We consider a trial wave function phi which is a continuous function of continuous parameter alpha. This alpha can vary. Then we find the expectation value of H using this get phi that is shown here. The expectation value of H is bra phi, which is a function of alpha, H get phi, which is a function of alpha, that divided by phi alpha, bra phi alpha, get phi alpha. Here phi is a function of alpha. As alpha varies, phi also varies. This is a continuous function of alpha and it is larger than E0. This expectation value of H is larger than E0. By choosing alpha so as to minimize the expectation value of H, we get the best estimate of E0. For that, we plot a graph between the expectation value of H along the y-axis and the continuous variable alpha along the x-axis. And when we find the various values of H for different values of alpha, we get a curve as shown in this figure. And the dotted line represents the ground state energy of the system, which is a constant. And if the curve approaches the value of E0, that is the minimum, that represents the ground state energy of the system. This is the usual procedure.